Right, so here we're in topic 2, probability and odds. So we want to differentiate a little bit between what probability is and what the odds are. Because you often hear, oh, the odds of so-and-so winning the Stanley Cup is 7-2, or, that's sad, versus the probability of them winning the Stanley Cup, which might have been 2 out of 9. Okay, so there's a difference there. And it's a different way of expressing the chances. So we're going to understand and interpret odds and relate them to probability. So explore, what are the odds of winning a game? Suppose that at the beginning of a regular CFL season, the Edmonton Eskimos are given a 25% chance of winning the Grey Cup. So the 25% chance, this is their probability. Probability. I'm spelling that wrong. I am. It's probability. So what is the event in the above situation? So we call something an event where we want it to happen. So the event in this situation is winning the Grey Cup. That's what we want to happen. The favorable event. Express the probability that this event will occur as a fraction out of 100. Well, we've been told it's 25%, so that would be 25 out of 100. And normally we would also reduce that to lowest terms, which would be 1/4. Now, what would be the complement of the event? Well, the complement of the event is all the situations where that winning the Grey Cup doesn't happen. So it would be not winning the Grey Cup. Okay. So express the probability that the complement will occur as a fraction out of 100. So that would be 75 out of 100. And again, we tend to put that in lowest terms, which would be 3 out of 4. Now, we can remember from our set theory that a complement, I'm using the wrong pen again. The complement is the leftover elements that do not belong to a particular subset. So we learned that in set theory. Complement is what adds up to the total, right? Okay. Now, when we talk about odds, we want the odds in favor of the Eskimos winning the Grey Cup. We express odds a little bit differently than we do probability. The odds in favor is the ratio of the probability that the event will occur to the probability that it will not occur. So, if we look at those chances out of 4, because we had 1 chance out of 4 for winning and 3 chances out of 4 for not winning, what our odds will be is we have 1 chance to win to 3 chances to not win. So this is for winning, and this is to not winning. So whereas probability was a part out of a whole, here we have a part to a part. So it's part to part. And in this case, the part is winning to not winning. Okay? Now, if we were asked the odds against, then we would switch that relationship. It would be 3 to 1. So this is not winning to winning. And as you can see, they're very similarly related to the odds for. So odds against is the ratio of the probability that event will not occur to the probability that it will occur. So if it's odds against, it's the unfavorable event chances to the favorable chances. So the big part is to remember that odds is part to part, whereas probability is part to whole. Okay? How are the odds in favor of winning related to the odds against them winning? Well, they're the same numbers, reversed order. Okay? How does the probability of an event relate to the odds in favor of it occurring? Well, probability, as we've said, is part over whole, whereas odds are part to part prime. Okay, so the part we're looking for compared to the part we don't want. Okay, and of course, we could also say that this is part to the whole minus the part. All right. How does the probability of an event's complement relate to the odds against the event occurring? Well, that would be part prime over the whole, which would be our probability. And if we were going to relate that, we would have part prime to part. Okay. So again, it's taking sections, okay, pieces of the whole picture. Now, in set theory, we learned about complements. We learned about the complement, and the complement can be used when we deal with probability. So the sum of a probability of an event and its complement always equals 1. So if we add the chance of something happening plus the chance of it not happening, it will equal 1, or the chance of it not happening is equal to 1 minus the chance of it happening. Okay, so it always equals to 1. Odds expresses a level of confidence about the occurrence of an event. It's a way to compare the probability of something happening to the probability of it not happening. And odds can be expressed in two ways. We can have odds in favor, so it's the ratio of the probability that an event will occur to the probability that it will not, or the ratio of the number of favorable outcomes to the number of unfavorable outcomes, so counting the numbers. Or we can have the odds against. And odds against means we're putting the unfavorable event first. Okay, so the probability the event will not occur compared to the probability that it will occur. And again, we can do that with the numbers of the events. So let's take a look at odds. Finding odds from probability. Suppose that a probability of event happening is 2 to 5. Calculate the complement of this event. Well, 2 is the part and this is the whole. So 2 is the part, 5 is the whole. So the remaining parts would be 3 out of 5. Because it's whatever you add to that top part to get your part prime. What are the odds in favor of the event happening? Well, we know that from here, 2 is our favor. Okay. So from here, we know 2 is in favor. And from this, we know 3 is the unfavorable. So the odds are going to be, and this is in favor, we write the in favor first, which is 2 to 3, which is the non-favorable. Now for the reverse, the odds against, we would write the unfavorable first and then the favorable. Okay? Now let's do some more practice with odds. Finding odds using sets. Consider the sets of hearts in a standard deck of 52 playing cards. Bailey holds all the hearts. He asks Morgan to choose a single card without looking. First, we want to define the universal set H of all hearts. Well, you can see the picture above. See, what am I writing? See oba. See above. But we could also write it as H is equal to, we write our funny little brackets, ace is 1, ace 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That's our set. Okay? Define the set of F of all the hearts that are face cards. So let's look at what we have here. We have these 3 face cards, which is F. Okay? So let's define that. So F is equal to, we have our Jack, our Queen, and our King. Then it says to find the set F prime. So that's going to be all the ones that are not face cards. So these would be F prime. So F prime is equal to, that's a weird bracket, so we'll redraw it so I can get it nice and pretty. It's all those ones that are not. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So nice little review of some set theory there, but also useful for probability because it's our sample space, our set. Now, we've got those listed out. Let's answer some questions. Find the odds in favor, so the number of face cards to the number of non-face cards of Morgan choosing a heart face card. So there are 3 face cards and there are 10 non-face cards. So probability would also be, probability is part for whole. So this is our odds. If we wanted to express that as probability, it would be 3 out of 13. So it's different ways of expressing the same information. Just remembering odds is part to part. And probability is part over whole. Okay, so this is part to part prime and part over whole. Find the odds against. Well, odds against, we just reverse 10 to 3. Now, if we wanted to write that as probability, it would be the probability of F prime, which would be 10 out of 13. Okay. Do you think Morgan is more likely to draw a face card or something different? Well, looking at both the odds and the probability, I think she is more likely to pull something different. Doesn't mean it's going to happen, but the odds are against her pulling a face card. Let's play around with some more odds. Okay, converting odds to fractions. So, oil and vinegar salad dressing is made using 2 parts oil to 1 part vinegar. So the ratio of oil to vinegar is 2 to 1. What fraction of the dressing is oil? Well, what we do is we add up the 2 parts. So 2 plus 1 equals 3, and that's the whole. And we have 2 parts oil, so it'll be 2 out of 3. Okay? Finding probability from odds. A computer randomly selects a university student's name from the university database to award a $100 gift certificate for the bookstore. The odds against the selected student being male are 57 to 43. Determine the probability that the random selected university student will be male. Well, the odds against them are, oh, I spelled that wrong. I got distracted. I got an alert on my computer. Against are 57 to 43. So that means that this is the not male, or male prime, and this is the male, or M. Okay, so the whole, if we're looking for probability, is 57 plus 43, which is equal to 100. So from here, we know that we have 43 males, so we can write 43 out of 100 is our probability that we will select male. Probability of selecting male prime will be 57 out of 100. So the not male. Okay, hope that's not the next question and I jumped ahead. No. Okay, so what this question is asking is actually this, and I just did a few more other things there. Okay, comparing the odds in favor. Suppose the odds in favor of Jack winning a race are 5 to 3. Suppose the odds in favor of Bill winning the same race are 6 to 4. Determine who has a better chance of winning the race. Well, for Jack, it's 5 to 3. So that means his probability is 5 out of, and this is in favor of him winning, right? So that means it's 5 out of 8, which we can convert to decimal, which is 0.625. For Bill, it is 6 to 4. So the probability of Bill winning is 6 out of 10, which we can convert to 0.6. So comparing those, and we want to put them in that probability terms because it is, the decimal means it's out of 100, right? Or out of 1. So that is a more accurate way to compare. If you compare odds, it's hard to compare them unless one part is the same size. So this tells us that Jack has a better chance of winning. Okay, so it's important to not just look at the odds, but to make sure that you've converted them to probability so that you can accurately compare those numbers. Example number 6, making a decision based on odds in favor. It says a hockey game has ended in a tie after a 5-minute overtime period. So the winner will be decided by a shootout. The coach must decide whether Layla or Karis should go first in the shootout. The coach would prefer to use her best scorer first, so she will base her decision on the shootout's records. So for Layla, she has 8 goals scored and 5 missed, and Karis had 10 goals scored and 7 missed. So we have to first figure out, from this it's easy to see their odds. This is 8 to 5, this is 10 to 7. That's a 5. I'm going to rewrite it because it looks weird. So those are our odds, but we really want to compare the probability. So the probability of Layla winning, or getting a goal, is 8 out of, and we add the 8 and 5 together, we get 13. The probability of Karis getting a goal, well, she get 10 out of 17. Now, they don't have a common denominator, so we're going to convert these to decimals and compare them that way. Layla probability is 0.615, and Karis's probability is 0.588. So even though Karis has scored more goals, her probability of scoring more is less than Layla's. So Layla should go first in the shootout. Okay, based on that. All right, there's probably other factors as a coach you might ask, like, oh, well, Karis has more experience taking the shot, so maybe that she improved. But we don't have that information, so if we're just looking at probability, based on this information, Layla should go first. All right, so probability and odds. All righty, odds express a level of confidence about an occurrence of an event. It's a way to compare the probability of something happening to this probability of it not happening. The sum of any event and its complement is 1 or 100%. So we use these to kind of define that. Odds can be determined from both probability and sets. So you can use set theory and set notation to help you kind of calculate your odds. And basically from probability, it's the probability for to the probability against for in favor, and it's the opposite for odds against. Or if you use it from sets, it's just the raw numbers for and against. Okay? If the odds in favor of event occurring are m to n, then the odds against them occurring are n to m. Probability can be determined from odds. If the odds in favor of event A occurring are m to n, then the probability is m over m plus n. If the odds against event A occurring are n to m, then probability of A not occurring is n over m plus n. When comparing two odds, you may interpret them better if you convert the odds to